Right, good morning. We're going to learn how to do a problem. We've studied the problems before where the guy's pulling the crate on a flat surface, but what happens when he's pulling it on an incline like this? In this case, it's a 12-degree incline, and he's pulling at a rope with a 25-degree incline on the pull up the ramp. The crate's 35 kilograms, so what we have to do is get all these forces going in the same direction, and then it basically works out kind of like he's on a flat surface. So let me show you how to do all this. First thing we're going to do is, like before, we're going to figure out the force that he is pulling up, because this is 185 newtons. I didn't label that, but I probably should have. We're going to figure out this force, and then we'll do this force here. Okay, so I'm going to pause this and do that math. I'll be right back. All right, so we figured out that the blue arrow, the f of x, the force in the direction that he's pulling, parallel to the platform, the incline, is 167.7 newtons. So 167.7, and the up force perpendicular to the ramp is 78.2 newtons. All right. Now, the next thing we got to do is look at the crate itself. So we're going to have an arrow coming straight down like this. That's going to be equal to Fg, which is going to be mass times gravity. So that's 35 times 9.81, and that works out to be right around 343. So that's 343 newtons. That's the length of this. Let me try to put that on there sideways. So it's 343. Now, also happening here is this force going perpendicular to the platform itself, coming down here. Try to get this best I can. Yeah, that looks good. Something like that. And then there's another force, I'll put in like pink, going this way. And that's the gravitational force that's being put on this box because it's on a tilt like this. All right, so I'll figure those out and I'll be right back. Okay, so what I did is I created a little sketch of this right here. So that is that right there. And what we need to do now is figure out what this force of gravity is. Now this here is what I'm going to call the force perpendicular to, now that's the orange arrow. See how that's perpendicular to the ramp itself. So the perpendicular force, and we're going to have a force, and let me do that in the appropriate color, or this will get ugly real fast. The force parallel, so that's going to be, that should have been two lines, parallel. That's not F11, that's the force parallel. It's the force of gravity that's parallel to that too. And let me put a G here. So this triangle right here is all about gravity's effect because it's on an incline. Okay, and we have to know that too, as well as all of these forces, as well as the normal force and the friction force. So we got a bunch to figure out here. This right here, and the other thing we got to know is this 12-degree angle here. When you, and I can show you later why that is. It's just going to take too long to do it now, but it has to do with alternate interior angles of a transversal, which basically is, I'm going to erase all this, but if you have two parallel lines and a line running through it, that angle equals that angle. And when we're done here, I'll show you that if we have time. So let me get that off there. Okay, so if we do the force of gravity perpendicular, that's going to be the adjacent side to this 12-degree angle. That's going to be a 12-degree angle right there. Let me make it a little bit bigger. So if that's 12, then that angle right there equals this angle here. Okay, I'll make them both yellow to show that. I don't know if I can squeeze a 12 in there maybe. Okay, but here it is on a bigger scale. And this is going to be nothing more than the same type of thing here, just flipped over. This is going to be the cosine of 12 degrees equals FG perpendicular over 343. And the pink one is going to be the sine of 12 equals FG parallel over 343. Okay, so when you do all that, the bottom one works out to be 71.3 newtons. And the orange one works out to be, this right here should have been orange. That's too bad I did that in yellow. But that works out to be 335.5 newtons. All right, so the next piece of this puzzle is to figure out the normal force. Okay, and that's going to, of course, go perpendicular to the ramp, and that's going to be Fn. Well, Fn equals, it's going to equal basically this force here minus this force. Okay, we're going to be subtracting those two things. So I'll write that out just for your notes and stuff. 335.5 minus 78.2 newtons. And that's going to equal 257.3 newtons. All right, so now I have the normal force. I'm going to circle that in bright yellow. Now I have the normal force. And I can start now working on the friction force part of this. And I have the coefficient of kinetic friction right here. And we know that just mu k equals Fk over Fn. And we know our normal force. Here's our normal force. So 0.27 equals Fk minus Fn, which is 257.3 newtons. So if we multiply those together, I am going to get, let's see here, 69.47. So we'll call that 69.5 newtons. Okay, so that's a force going this way, 69.5 newtons. So now, what we do, and remember, that's the force of kinetic parallel. Okay, so we got some parallel forces going on here. What we have to do is to take his pulling force. Let me circle these in bright, bright purple. So I got to take this force here and subtract from it the other forces going in exactly the opposite direction, which is this one and this one. Okay, so it's 167.7 minus, let me get just a little bit brighter color so that sticks out. So it's 167.7 minus 71.3 minus 69.5. And that turns out to be, make sure I'm recording. I am. Okay. We're all good. That turns out to be 26.9-ish newtons. So that's the F net force on this box going in this direction here up the ramp. And from that number, I can now use Newton's second law, F equals ma. So 26.9 equals the mass of the crate, which is 35. Congratulations, we're almost done. Times A, and we divide by 35. And A equals somewhere around 0.77 meters per second squared. And that is the acceleration of the crate. What a problem. We should go take a couple laps around the building and celebrate. I will talk to you later.